Welcome, everybody. My name is Guy Royce, and I am confused. I'm the organizer of the Columbus JavaScript user group, which is what we're kicking off here right now. Tonight, we've got Rob Richardson. He's going to be talking about Vue.js and TypeScript, Vue.js and TypeScript, going together like peanut butter and jelly, or something like that, right? There's definitely a peanut butter and jelly metaphor in there. If you're watching on Twitch, go ahead and drop questions in the chat on Twitch, and I'll make sure that Rob gets them. If you're here in Zoom, then go ahead and just ask your question, and I'll watch the Zoom chat as well. And if you're on Twitch and you want to join us on Zoom, you can go to meetup.com, go to ColumbusJS.org, and there'll be a link, and you'll be able to find the links to the Zoom as well. So with that, Rob, welcome.
Thank you.
The floor is yours.
Nice. Let me share my screen. This morning I couldn't get the Zoom box to go away, so there it goes. That was interesting. Vue.js and TypeScript working together like peanut butter and jelly. I did this talk once in the Middle East, so it was working together like hummus and pita, and that was really fun. Here's the part where I tell you I'm definitely going to post the slides on my site tonight. You'll hit me up tonight, tomorrow, next week, next month. In time, you'll get tired of pestering me, and you'll send me an email. And in about 6 months, I'll reply and say, no, I'm definitely going to post them on my site tonight. And I'll never post them at all. I've been that person chasing the speaker for the slides, and I never got them either, which is why you can go to robrich.org right now, click on presentations here at the top, and here is Vue.js and TypeScript working together like peanut butter and jelly. Both the slides and the code are available online right now. While you're here on robrich.org, click on About Me, and you'll get here and see some of the things that I've done recently. I'm a Microsoft MVP, a friend of Redgate. I'm a single store developer evangelist, and I've helped organize AZ Give Camp. AZ Give Camp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building software for them Friday after work. Sunday afternoon, we deliver that free software back to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp here in Columbus or wherever you are, hit me up on email or Twitter, and let's get philanthropy installed in your neighborhood as well. Some of the other things that I've done, I worked as a core contributor on Gulp in version 2 and version 3. And my claim to fame, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So there's my coveted .NET Rocks mug. We're here to talk about Vue and TypeScript. We talked about this guy. This is definitely not a 101 talk on Vue or TypeScript, but let's level set just a little bit if you're not familiar with either technology, and dig into, what is Vue? Vue is a SPA framework like Angular and React. Vue focuses on developer productivity and easy learning. They intentionally reduce the concept count to make leveling up in Vue really easy. But like React and Angular, they all have a component-based approach. They all have virtual DOM. They all build with Webpack and Babel. They all have a CLI to be able to get started. They all output CSS, HTML, and JavaScript to the browser. They all have a rich ecosystem of plugins. So if your preference is React, Vue, or Angular, you really can't make a bad choice here. Any of them will do just fine in making high-performance websites. Now, like all things, you can write really awful code, and you can make a badly performing website in any of them. But all of them have great tools for being able to do great things. Where they differ? Well, with Angular really optimizes for the IDE. And so you have a whole lot of things where if you have an IDE that can run that function, it works out really well. If not, then it's kind of difficult to drive Angular. Angular has TypeScript built in. And so to begin with Angular, you must first begin with TypeScript. React. React has JSX. And JSX is a mix of HTML and JavaScript together. Well, technically XML and JavaScript. And because React has JSX, we don't separate concerns on technology boundaries. We can separate concerns where it makes sense for your business application. That's really interesting and compelling, but to do React, you must do JSX. By comparison, Vue has single file components that have each section for that content in the spot that makes sense. We have an HTML section, a JavaScript section, and a CSS section, but all in one file. So we don't need to go find the other file that has the other piece, but we can also code in the language where it makes the most sense to code here. React, Vue, and Angular. My completely biased opinion. Angular is built for tooling. It helps make tooling powerful, like IntelliSense. React is built for Facebook, for the kind of problems that they have. And Vue is built for developers. When you grab these slides from robrich.org, click on these blue links, and you can get more details about the comparison between Vue, Angular, and React. But again, there's really no wrong choice here. I'm going to choose Vue for this demo just because it's really fun, but you could do similar things with React or Angular. To get started with Vue, we'll come here and we'll say Vue create my app. I'm going to come in here right there. Vue create my app, and it takes a little bit to spin it up, so I've already started it. But now I can go pick either Vue 2 or Vue 3 or manually select my features. I'm going to manually select my features. I can choose the Vue version. Vue 3 just barely came out, and it's really, really nice, but not a lot of plugins have caught up yet. I'll turn on TypeScript. I want to turn on PWA support, so it'll build me that service worker. I want to include Vue Router, Vue's Flux Store. I want to build in Sass. I like having a linter and a formatter. Unit testing, yeah, I'll do testing. End-to-end testing, yeah, I'd like to pull into Cypress. As I pick these, now it's going to interview me and pick the particular things that I want in each of these sections. So let's pick some options here. Sass with Dart Sass. No, I'll choose Node Sass. That works. What ESLint version do I want? And I can wander through each of these selections, picking the things that I want. That's really cool. Once we're done, we get a project not that unlike this. And here's the details that we have. Oh, I opened the wrong folder. Let me, oh, actually, no, I didn't. Yeah, I did. Let me open the correct folder here. No. I would like to, okay, let me close folder and do it the hard way. Close folder. Open folder. Here's a Vue app. There we go. Now this is pretty much what we get when we run that through. I did choose TypeScript, and I turned off Vue Router and Vuex. Oh, I guess I do have Vuex. And so we can see that we start out with a main.ts. Now I chose TypeScript here, so we see that. And it starts by grabbing the app. The app is kind of the main piece. And here's where we can see Vue's single file components. Here's the template section, which includes all of the HTML pieces. Here's the style section that includes all of the CSS pieces. And in this case, it doesn't have any JavaScript. It does include these two pages. So let's open up one of the pages. Here's the home page. And the home page happens to include a Hello World component. So there's that Hello World component. And we can pop open that and start to see that mechanism. In this case, the template section is quite big. But now here's our script section. Here's our CSS section. We have a scoped variable. That means that it will rewrite these rules to be specific only to this component. And these styles won't leak out into parent components. We can also see that we have lang equals ts. That's our signal to say this is a TypeScript-based component. Now, because it's a TypeScript-based component, we can't just say export default, open curly, close curly. Rather, we have to say Vue.extend so that TypeScript understands what this object is. It is a Vue component. Once we've got that in place, now we can just cruise through and we've got a great setup. In this case, because we're using Vue Router, we have a home page and an about page. And if we start it up here in the browser, then we've got our Vue default app. Here's the home page. Here's the about page. That's pretty cool. We just said Vue create my app, filled in, let it interview us and filled in all of the questions and fired up an app and it's ready to go. So we've got a Vue app. Next up, let's take a look at TypeScript. Vue was a great SPA framework like React and Angular that allows us to get started quickly in building a thick client application. TypeScript is a superset of JavaScript. Anything in JavaScript is valid TypeScript. TypeScript's goal is to say, did I call it correctly? Here's a sample line in a file that I was making up where it says, call this critical function. I'm going to pass in a customer and invoice. Okay, those make sense. Date. And then true. What is true? Do I need the curly braces on either side? And then I have false. What am I setting to false? And now I have 2 commas. Was that a typo? Or was that on purpose? I don't know. And that's where TypeScript can really help, because TypeScript can give us some hints to be able to know if that was intentional. Now, how do we solve this without TypeScript? Well, we'll probably do something like this. I'm going to call some critical function and I'm going to pass in this object and I'm just going to build it in place. Customer, invoice, date, config. Now I have named parameters. Inside my function, I'll destructure this, spread this object right back out and grab those specific parameters. Now I have named parameters, so I know that I'm going to get a little bit more descriptive names in here, but still, did I call it right? I don't know. One of the things that I often stumble over is exactly this, where we've got jQuery and we call jQuery.ajax. Do I need to pick something first and then call .ajax, or do I just call $.thing? Here I said, go pick a foo and run Ajax on that foo. Now that's not right, but JavaScript isn't going to tell me that. jQuery may even pave over that and make it work by accident, which is kind of cool. But that's where TypeScript can come in. TypeScript is good at catching common typos and mistakes. It is a superset of JavaScript, so anything that is valid JavaScript is valid TypeScript. And if you do nothing more than run the TypeScript compiler across your JavaScript, you may learn things, and that could be really cool. But TypeScript adds optional type hints to the design time experience. Now, it doesn't restrict the runtime behavior. If I cast something into a TypeScript interface, I'm not going to drop properties. Simultaneously, when it compiles into JavaScript, and the JavaScript is what runs in the browser. So if your TypeScript types don't match your runtime behavior, your application still works. The types are only for design time. They're design time helpers. TypeScript is free and open source, and you can just download it from NPM. So for example, in TypeScript, I can start to use newer features because they're baked into TypeScript before they may be published as final things. Now that has led to some interesting scenarios, but for example, the nullish coalescing operator was available in TypeScript before it was available in all the browsers. That's cool. TypeScript then can transpile that into place so that I can start to use these new features, but still support older browsers if I need to. Now that we have evergreen browsers, that's less of a concern, but it's really nice that I can use these features straight away and get those type helpers. Private fields actually came to TypeScript before they came to JavaScript with a little bit different syntax. So once they came to JavaScript, then it was a little bit of a shim to make it work in TypeScript too. But this optional chaining, That came to TypeScript first as well. So TypeScript, it validates that the types match. It doesn't validate your business logic. If you use TypeScript as the one and only unit test in your project, you should probably avoid TypeScript. It's not helping you. TypeScript is really about validating that you called it correctly. But you still need unit tests around your system. You still need to have integration tests that prove all your components work together. This is not a testing framework. It is a double check for syntax. So TypeScript, how do I get started? Well, the first step is to rename your file from .js to .ts. That puts it in the purview of TypeScript. And now we can do some interesting things. So here's my say hello function. I take in a name and I return hello and my name. Now, if I want to, I can upgrade this function inside TypeScript to provide optional type inference helpers. Now I'm going to say colon string. That says what I expect you to pass me is a string. Now, if you happen to pass me a number or an object or anything else, it will still work. What runs in the browser is JavaScript. But with this type annotation, I can get some design time help to say, did you call it with a string? I'm also returning a string out of this function. And so I've documented that as well. It's really cool. I'm making my intent more clear. If you're consuming my application, this function, you know how it works straight away. Your IDE is going to help. Can TypeScript validate usage within functions? Yes, it can. This same mechanism, now once you call it, it's going to say, hey, did you pass that in as a string? As I call different functions, as I use types within the function, it can note whether that type was intended to be nullable or not. It can document which type it was and know if we have accidentally cast it or treated it differently. Yes, TypeScript is amazing even within functions. Here's an example of doing that, and we can pretend this is exactly in a function. Here's my app.ts. Now, this is valid JavaScript, so maybe I just renamed this file. I have a const x. A is B, C is D. Did I build that object correctly? I don't know. Let's create in a types.ts an interface. Export interface customer info. I'm already getting more information. I know this is about a customer. That's really helpful. I'm making my intent more clear. Now here in this interface, I'm going to say A is a string, C is a number, and O is a string. Note this question mark here. O is optional. So if I didn't specify an O property, that's okay. But I know that C is a number and A is a string. So I'm going to import customer info from types, and I'm going to create this variable X as a customer info. Now, because I've specified that this is a customer info interface, it's going to go validate these properties. Yes, A is a string, and C, I'm going to get red squiggles under this D because, well, it's not a number. Now, this will work just fine in runtime, but in design time, it'll help me identify that I probably meant to make D a number. That's really cool. Now, does that mean that I have more code in my system? Well, as TypeScript transpiles all the pieces, it won't actually include this customer info anything. That goes away. That's all design time hints. So I'm not importing an extra file. Rather, the customer info gets stripped, this import statement gets stripped, and my code is exactly as big as it was before. But in that design time experience, I've now made my intent more clear, and I can catch those errors much more quickly. This is a great thing of inside of a function, I can get TypeScript helping me as well. Great question, Doug. Thank you. So TypeScript, it can figure out types by itself. And so if I call it passing in a string, it can guess that that function should have taken in a string. And if I return a string from that function, it can validate all the things that call it, presume that that function returned a string. That's really cool. TypeScript can guess a lot, but giving it some more clues helps a lot. So I would say, pro tip here, annotate as much as you can because you're further identifying your intent. Your intent explained through your code will be really helpful for the developer following along behind. Well, when I code, the developer following behind is me shortly after I've forgotten how it works. So do future you a favor by documenting what you meant by this. And that's where TypeScript can really help. So that's Vue and TypeScript. Any questions on the basics of Vue and TypeScript? Awesome. Well, let's do a bunch of demos in Vue and TypeScript. We have this application that we've built that has some components. It has some assets. We have a store. Here's our router that allows us to navigate between pages. This is actually really cool. We have a Webpack chunk name. The way to lazy load components is to import them in the middle of doing the thing. Now, I do have TypeScript configured, so I do have this tsconfig, and the Vue CLI was actually able to build this for me. I didn't end up needing to code any of this, and that's really cool. Okay, so this tsconfig is actually scripted for me. I didn't need to type any of this, and this is the definitions that TypeScript needs to be able to transpile my TypeScript code into JavaScript code. Now, in this case, I'm targeting ESNext, and I'm using some other options that allow me to do interesting things. Webpack, all of that was scaffolded for me, and I didn't need to do any of it. So I come in here, and I'm going to say npm run serve. And once I've done npm run serve, now I can browse my application. And what's running here in the browser is JavaScript. I'm not running TypeScript in the browser. I'm running JavaScript. That's okay. So first up, let's go grab the first folder. I'm going to say copy in folder 1 into demo. As you grab the code linked from robrich.org, we'll have a different folder for each of the steps that we'll dig into. So I was here in step 0, and here in step 1, I'm going to add some ESLint rules, and I'm going to fix up the ESLint content. So I happen to prefer semicolons, and so I put semicolons at the end of all my things. Step 1, and my browser is ready to go. So my application is still running my JavaScript code. That's cool. Now, I found this Beautify library. I think Beautify is kind of cool. It has some interesting UI pieces, and I want to install this. Okay, so I can use the Beautify plugin, Vue add Beautify, and pull it into my TypeScript app. Let's go grab step 2 and add Beautify. Oh, and let me put it in the correct folder. There we go. So I've got Beautify, and now with Beautify, I have this Beautify plugin here, and it pulls in Beautify, and wait a minute, I got some red squiggles. Beautify was a library that was written in JavaScript. It knows nothing of TypeScript. So I get red squiggles here. I also get red squiggles here. Beautify knows nothing of TypeScript. And so as TypeScript goes to try and infer what is Beautify, it stumbles. Now, when I build here, I'm building the TypeScript into JavaScript. So, it's doing its best to go figure it out. But my cursor has started tracking my pointer has started tracking the cursor, whether I like it or not. So I'm going to go Google for a little bit, and I land here on this comment that says, well, Beautify actually has this types folder that gets us started. So inside type roots, add Beautify types, and then go add this Beautify, and that should get us to the goal. Yep, here's all of those fails where Beautify is not known to TypeScript. But my app is still running. That's pretty cool. Let's go grab the next level of content. Let's grab step 3. And that's where I set that piece into place. I come in here to my tsconfig and I add Beautify and I add Beautify types. And now my TypeScript is going to rebuild. And oh, I actually need to restart it because I've changed my tsconfig. But now it can rebuild. And now my TypeScript understands how Beautify works. It's using those types. So I come in here to main.ts and that red squiggle is gone. I come in here to my plugins and that red squiggle is gone. That's cool. Now that was kind of a hack, a one-off. But now if I come into my application and I'm racing the compiler here, 40%. I love how both of these numbers actually jump up as the TypeScript transpiler opens each new file and locates the dependencies within that file. It will actually count up the destination modules as well because it's locating more things. So now it's running through those and transpiling them. That's awesome. But if I come in here to my browser, let me grab it this way. There we go. My app, oh, it's in the middle of transpiling. That's why it's not working. Let's wait for this transpilation to finish. It's almost there. 800, it's almost there. 840, it's almost there. Push it over the goal. There we go, chunking the assets. Now we've got our application. So Beautify is this library for Vue that does material design. And now I have my material design in my application. I have this nice header. I put the Vue icon on my about page just so that we could see it. But we've got that same mechanism inside of our application. We've got Beautify and we've satisfied TypeScript. That was cool. Okay, so I want to come in here and I want to add some new components. Let's add our first component, a counter component. So I came in here and I said, new file. I created this counter component. We see in this counter component the 3 sections. I have the template where HTML can excel at what HTML does. I have this section for TypeScript where the JavaScript can excel at what JavaScript does, in this case, TypeScript. And I have a CSS section where CSS can excel at what CSS does. That's cool. Now here in this component, we're using standard handlebars syntax here. So I've got the curly brace, count, curly brace. So let me go grab that count variable here at 0, and I'll just output it there. Here in Vue, we have this @ which binds to events. And so when this button gets clicked, I will run this add function. Here's this add function. It will increment count and it will emit this event. That's cool. Now I emitted this event because here in this playground page, I have not only the counter here, but I'm also consuming this counter from the calling page as well. So here is this calling page, playground.vue, and I have my counter component. When the count changed event happens, I'm going to call count changed. Now I did the normal thing. I documented that I'm going to take an account, but I made a typo here. Here it says count is string. Now back here in my app, we know that count changed will export this count changed, and count changed is a number, not a string. But we can see in our application, it works just fine. TypeScript got out of the way, and what's running in my browser is JavaScript. This number is getting pushed across. And so one of the bummer pieces about TypeScript in Vue is that we don't get type checking across components. Vue 3 is rewritten in TypeScript. And so I wonder if in Vue 3, we will get type checking across components. But that's really cool to notice that that may be one of our barriers. If you're expecting to get type checking across components in Vue, then that's not available. Okay, so we've got our new component. Let's add some more components here. Now here I've got a lot more components. In my playground.vue, I added the counter, and here's outputting the count. I've got my icon playground. I have my navigator. Let's take a look at how those work. Oh, it's still transpiling. My icon playground is pulling in some font awesome icons, so that's pretty cool. And I don't have a whole lot of TypeScript going on here, but I did declare my TypeScript component so that TypeScript understands how to consume it. Here in my navigator component, I'm testing two different things. I'm creating a link using Vue router, just 2 equals, and then I'm also doing a navigation programmatically. This .router.push to go to my homepage. So let's go test that out with our component. Let me refresh here. I'm probably also racing. Oh, haha. I just dumped out of the terminal. So that's interesting. npm run dev. No, npm run serve. Let me create a new terminal. Now we get to race the compiler again. Go, 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 go. What PowerShell module do I use to get the ZSH bash-like look and feel? Ooh, yes, this is Oh My Posh. Scott Hanselman does a really good video about setting up Windows Terminal for Oh My Posh, and it is so cool. So yeah, I've got the Git integration right here, the paths in a really elegant way. I don't know what updated, but it likes stealing my cursor now. And so you can see anytime the text changes, my mouse pointer gets caught. Now I want to find a way around that one. But outside that, Windows Terminal is beautiful. It has been getting stuck on some content. And so I don't know why it just like dies sometimes, but I updated and now it dies. There we go. I've got my counter component and I'm able to publish that event to other things. I've got my font awesome component because Vue is awesome. And here's my navigator component where I can link either with just Vue router or programmatically. And we see that that works in both cases. That's cool. Now, one of the things that's really cool here inside this code is this $router.push. Now, Vue knows that $router is a thing and has told TypeScript how to do that here inside this shims.vue.d.ts. So that's really cool. All of the Vue pieces, including Vue router and Vuex, are just available to us inside TypeScript. We have those type definitions for us. That's really cool. Well, let's grab the next section, robocopy /e step 005. No, 05. Oh, I think we just finished that one. Step 6. Okay, so here in step 6, I was enjoying, let go. I was enjoying this Beautify form control. Now, the beauty here about this Beautify form is that you can enter things, and when you don't fill it out, it will document that it's required. So, but once I fill it out, robjohn@doe.com, now it is valid. And I have this validate thing that will only run, it's disabled now, until I do all of the pieces. That's cool. So I can flip over here to the code. I have my template content. I have my TypeScript code. Well, in this case, JavaScript code. And so I'm going to go copy that into place. Here is a form where I've copied all of that content into place. Here's that content. I grabbed all of the Beautify pieces and set that in place. That's really nice. I also grabbed the JavaScript and set that in place. Uh-oh. Form reset, form validate, form reset validation. Now, the interesting thing is, in spite of the fact that this is TypeScript, and we get all of these errors, my code is running correctly. So if I come in here to my page, I can see here's my form, and it's working just fine. In the browser, in JavaScript, everything is great. But in my IDE, in TypeScript, it doesn't know what form is. It says, well, form is a view or an element or a view array or an element array. How do we teach TypeScript how this JavaScript component works? Well, let's do this. Let's create a computed property, and we will call this form. And we will return this $refs.form as, well, let's call this HTML form. Well, we have this HTML form element. That's pretty cool. Now, instead of this .refs.form, I can just call this .form. I'm moving in the right direction. Validate and reset are normal methods inside of a form, but reset validation is not. So let's say, let's build this view form element. And I just made that up. Let's come up here and create an interface. Let's say export interface view form element. And this is an HTML form element. And we have a validate function that takes in nothing and returns a Boolean. We have a reset function that takes in nothing and returns nothing. And we have a reset validation function that also takes in nothing and returns nothing. No, this is a type. Okay, so this type is a form element, all the things in form element, and all these other things. Because I've now cast my item to this thing, and I can even be more descriptive and say it's returning that thing. Now TypeScript knows that when I say, oh, this .form, then I know that I have those properties. Now I've done this. I've said as. Now when I said as, what I said was, I know better than you, TypeScript. I know that this is what I expect it to be. So from now on, treat that as a thing. It kind of breaks TypeScript's automatic inheritance, automatic type checking, but I know in this case, I'm right. That's cool. Here's our first mechanism of including JavaScript libraries in TypeScript. We can create a variable, create a class, a type rather, and give it the properties that we need, and then cast it as that thing to get at that element. So I'm going to go grab this code 7, set that in place. And now I've done exactly that. Now we're going to transpile all the things, but I have this type up here. Oh, I actually pushed it into another file in this case. Here inside types, I have this vform. And vform defines HTML form element and component and these 3 methods, just to make sure that I'm covered. Now my TypeScript compilation works just fine, but my application worked just fine in my browser before. it still works just fine. I still get the same validation details, and that's really cool. Once I fill things in, let me pick an item. And once I've validated all the things, then my submit button lights up. It still worked before, but now with this helper, I'm able to do that as well. Okay. So now I want to do some interesting things. I'm noticing here in my component that it always starts with 0. Now that's okay, that's interesting, but I'd really like it to start with a random value. There's this library called Lodash, and Lodash is interesting. Lodash has lots of functions. I agree, you might not need Lodash, but let's pretend. Here inside Lodash, I have this function called string properties. Nope, it's in the math section, I think. Or I can come back to the top and I can search a random function. The random function takes in a lower and an upper and will give me a random value. Okay, so I've npm installed my Lodash library. Let's import random from Lodash. And then here I'm going to say, actually, this is random. Is it random? Yeah. I'm going to say 0 and 100. Go pick a random number. Ooh, red squiggles. Lodash is a library that was created in JavaScript, and Lodash knows nothing of TypeScript. So let's talk about a new strategy that we can use to build up a mechanism to teach TypeScript how Lodash works. I'm going to come in here to source. I'm going to create a new file, and I'm going to say this is lodash.d.ts. Now, this is a type declaration file, .d.ts, and so I'm not going to import it. Rather, I will say declare module Lodash. Once I've declared module Lodash, and as soon as my IDE catches up, then I'll now get red squiggles on random. Okay, so let's say the Lodash module also includes an export function random. I'm going to say here's min, and it is a number, and max, and that is also a number, and it returns a number. Okay, I've just built this type declaration. Now I'm not telling, not there, counter. I'm not telling VS Code to import it. Rather, it's just looking through my mechanism to see it. Now, VS Code often needs a kick to restart to go find new content inside of type declarations. So I'll just kick off VS Code again. And now I know how this random library works. Now, the cool part here is I no longer get red squiggles on Lodash or on random. I have taught it how this Lodash function works right here. It takes in a min and a max and returns a number. Now, the cool part here is if I now pass in only one item, it'll go, hey, you didn't pass in the other piece. Or if I pass in a string, it's going to go, hey, that's not a number. Well, as soon as my IDE catches up. But it will help me by giving me red squiggles around the content within this application. So I'm going to set this to 100 and, oh, it's still initializing the TS framework. Nice. Our application now still behaves as we expected. We can start with a random number and we can move up and down and refresh the page, and it will start with a different random number. Now that's cool. That's our next technique. We can create a type declaration file to teach TypeScript how certain libraries work. Now, in this case, Lodash has a few functions. I didn't document the floating parameter. I could spend a lot of time building out the type declaration for Lodash if I was to build out every function within Lodash. Yeah, that would be a lot of work. So does the default Vue app load all star.d.ts files in its tsconfig JSON? Yes. By default, the TypeScript compiler will go find all of the .d.ts files and pull them in. And so I don't need to import a d.ts file. I just need to have it in my project. Great question. Thanks, Matthew. Sliding a little recommendation for WSL in here. Yes, WSL is amazing. I completely agree. Okay, so we've got the d.ts file, and it's building out what we are using in Lodash. But does that mean that now I need to document this function and this function and this function? There's a lot of functions inside Lodash. Well, there's a really cool project here called Definitely Typed. And Definitely Typed is that collection of type declarations for a lot of open source libraries. So if you can imagine it, here are the type declarations. And every package here inside this Definitely Typed repo gets published into NPM as a definitely typed at types/thing. So I can search for at types/Lodash, and I get to this package that I can use to install. Here's our next technique for including JavaScript libraries in TypeScript. npm install --save, and in this case, it didn't tell us save dev, at types/my-library. Now, I haven't done that in this project just so that I could build that .d.ts, but if I had installed this package, I would get the TypeScript bindings for my library straight away. Typically, when I install a package from npm, I will then turn right around and install at type/that package, just kind of by default, so that I can get type declarations. Now that is really cool. I've got type declarations for my TypeScript, and I can do what I need to do. So let's go grab step 8, which is adding my type declaration file. Or step 8 is adding the code to build the 9. Adding the code. Step 9 is adding that type declaration file, and that's pretty cool. Let's go grab step 10. I'm cruising around here on the internet. I'm having a lot of fun. I land on this page called Vue Awesome. One of the cool tricks of the trade is if you Google for awesome and your thing, you'll probably land on a GitHub repo, not that unlike this, that just shows, well, in this case, a lot of really awesome components. Now, this is a curated list of really cool components inside of Vue, but it's really sweet, and it's really a lot of components. So I came up here and I said, I want a Parallax component. I think Parallax would be kind of cool. Click on Parallax, and here's a bunch of Parallax libraries. Well, I chose Vue Parallax Js. Here's Vue Parallax Js, and it is definitely a library that wasn't built with TypeScript in mind. Here's the prototype, and when I'm wiring it up here in export default, here's this install mechanism. And so I have here inside my main.ts, I have a reference to Vue Parallax Js. And then I say vue.use Vue Parallax Js, and it goes, I have no idea where you're going. Okay. Now we could start trying to create a new type declaration file, but well, that's really hard. This library was not built with TypeScript in mind, and was definitely not built with to make that easy to use. So let's go search for a mechanism. Here on the Stack Overflow, it answers the question, how can I auto-generate a type declaration file? I can say tsc -- declaration and pass in some TypeScript file, and TypeScript will infer a type declaration file. Let's do that. Oh, it looks like my terminal died again. That stinks. So I'm going to cruise here into node modules, into Vue Parallax Js. And here inside the lib directory, nope, cd lib, I have these files. Vue Parallax Js.es.js. That's the type, that's the library that I'll end up loading. So let's copy that Vue Parallax Js. Oh, actually, we need the regular one, this one, into Vue Parallax Js, but I'm going to rename it TS. Now, all JavaScript is valid TypeScript. So I just created a TypeScript file. That's cool. Now let's use TSC and let's say -- declaration Vue Parallax Js.ts. Oh, there was too many L's. That's definitely not going to get us through the goal. Now it's going to go look at that TypeScript file and infer a type definition file. Or it's going to crash my terminal again. There we go. Now, of course, there's a lot of things that it doesn't understand, and that's totally fine. But if I come in here into node modules and I cruise down here to Vue Parallax Js, and I come in here to the lib folder and I pop open this type declaration file, that can be a good start. Oh, did it not open it yet? Let me try that again. There we go. So it says, I think the interface might look something like this. Well, that's cool. That definitely gets us started. Now, together with looking at some other type declarations, we can come back into here and let's look at 11. Wow, my machine is really being grumpy at the moment. Okay, so we've got this now. We've got this type declaration file, and it started us off there, which is pretty cool. Here inside our app, I've then inferred that and kind of built out what I expect that type declaration to be. That's cool. Now, I love that generating that type declaration file, though it didn't give me the perfect answer, got me on my way to figuring that out. And now inside my main.ts, Vue Parallax Js is just fine. Now, this Vue Parallax Js was not built with TypeScript in mind, so there are no type helpers here. But once we race the compiler, we can pop open our application. And here on the home page, we have that nice parallax effect. So you can see that the column on the left is scrolling at a different speed than the column on the right. Now, we did need to help it a little bit by giving it that type declaration file, but we were able to make that library work as well. So this was a bunch of really cool techniques. Yes, NAD, also the official packages may lag behind their own .d.ts definitions. Yes, having outdated type definitions is a good open source opportunity. I completely agree. Ooh, do the third-party .d.ts files at definitely type tend to lag behind the latest versions of the package? Thank you for answering that, Matthew. Great question, Doug. We were able to look at a lot of different techniques for including JavaScript in our TypeScript project. Now, this is not in the order that we saw them, but here's a good prioritized list of ways to identify how to include JavaScript libraries in your TypeScript project. First up, use libraries built in TypeScript. Now, if it's built in TypeScript, this is already solved. That's really cool. You're probably picking a library because of the functionality it gives you, not because of the language it was written in. So this is probably one of those things that, well, yeah, if all else is equal, but all else usually isn't equal. Next up, go look for a type declaration inside definitely typed. Install @type/yourlib, and you'll be able to get the type declarations for the content that you needed pulled into your project. Next up, you can handcraft a type declaration file, a .d.ts file. Now, we didn't import it, we just built it, and that allowed VS Code to know how our object worked. TypeScript now understood how this library worked and was able to leverage it. If building a .d.ts file is too intense, you can start by moving your JavaScript file into a TypeScript file and generating a declaration file. tsc-declaration file.ts. Now, that's probably not perfect. It's probably not even sufficient, but it may get you past that hurdle. And then you can start to handcraft your JavaScript file and do some amazing things. Next up, you can say bad as any. If you have something that isn't behaving, TypeScript isn't able to figure it out, we can use this as syntax to be able to grab the content that it is. Now, next up, we can add a @tsignore. tsignore comments say, TypeScript, just don't worry about this thing from now on. Now, that is kind of dangerous. We've just basically said, opt out of TypeScript's type helpers. And so you can create an ESLint rule that says this @tsignore comment is not allowed. But here's a bunch of techniques for including JavaScript libraries in your TypeScript thing. Use libraries built in TypeScript, grab types from definitely typed, handcraft a declaration file, generate a declaration file, and cast things as any. Now, any is one of those things where it's like, I don't know. So you can also create an ESLint rule there to say ban any. And then finally, tsignore. These are all a bunch of really cool strategies for including JavaScript in TypeScript. When would you want to use TypeScript with Vue? When you have a large project that needs to be durable for a good amount of time. If this project is going to live for a long time, it's really helpful to have these type declaration checks inside your application. I find key string is a pretty nice, nifty generic any type for an object. Yes. Any might also be necessary if you find a package has lagged behind its type declarations. Yes. There are good instances where any is a good solution. If you can avoid it because that might be more helpful. Unknown is a good substitute for any when you can't get the thing to work. And unknown is a little bit gentler than any. TypeScript is really good at allowing you to communicate better between developers because you can make your intent clear by documenting both the in and out types of your content. It's a good go-to for a first check of your syntax, but TypeScript is definitely not your only unit test. When should you avoid TypeScript and Vue? Well, if you depend on, pardon me, if you depend on a lot of components and libraries without type declarations, you're probably going to spend a lot of your time writing type declaration files. You may choose to opt just for JavaScript to avoid that additional time of supporting TypeScript. If you have quick doodles, or if you have a mechanism where you're not using the CLI, then using TypeScript is not effective. TypeScript is great when you have a command line that can transpile the content. But if you don't have that command line to transpile the content, then you'll need to find another mechanism to do this. One of the great things about Vue is that you can use it just by including a script in your page, and you can include that script from CDN. Well, in that case, you don't have a transpilation step, so you can't include TypeScript in that project. If you're going to treat TypeScript as your one and only unit test, then TypeScript is not a good fit. Jeff Fritz is one of the creators of TypeScript and has created the Vue Enterprise Boilerplate. The Vue Enterprise Boilerplate used to be based in TypeScript, but now is not. It's now purely in JavaScript. As you grab these slides from robrich.org, click through to learn more about Jeff Fritz's thoughts on why he removed TypeScript from the Vue Enterprise Boilerplate. And so that's what's really cool. There are lots of elegant solutions to including TypeScript in your next JavaScript project. And it's really helpful for being able to catch those quick errors. If you're using it for your only unit test, though, go back to JavaScript and get to the point where you've got a test bed set up, and then you may be able to add TypeScript later. For those watching this video later, hit me up on Twitter at Rob_Rich. For those who are here in the room, what are your questions?
I had a question in chat. I'll just repeat it. Angular prevents the app from compiling to JavaScript if there is an error. Can you, or how can you configure your Vue app to do the same thing?
Good question. When I'm in the dev server, Vue will try to continue running as best it can so that I can experience my content. But if I do a Vue build and I get a TypeScript error, then it will stop. And it'll stop with a non-zero exit code so that my CI system knows that that's why it failed.
Can you configure the dev server to not do that?
Can I configure the dev server to not finish compiling if there are TypeScript errors? I've never tried, but I'm sure there is. The Vue dev server is just Webpack underneath. And so you can take control over it either in the Vue config.js or by doing a Webpack config yourself. Great question. Thanks, Matt. Guy, are there any questions on Twitch?
No, actually, I think we have like 3 viewers on Twitch, and I might be one of them. So I'm sorry, there's 1, so I am the viewer. Either that or it's Matt.
There you go.
So yeah, no questions on Twitch. So
very nice.
I have a quick question. If I wanted to add TypeScript to a Vue project that I've already started and I ran, would I use the Vue CLI to also put in the scaffolding for TypeScript in that? Or is it going to like start putting in like my hello world and overriding like my main JS or app.js or Vue components?
What I typically do in that case where I have an existing project that I want to upgrade to TypeScript, there's a couple of different ways that you can do it. I'll generally create a new folder and scaffold out a new Vue project. And once I've got the config files, I'll diff my old project and my new project, copying over the tsconfig and maybe a few things inside my packages.json where it's going to define the scripts. So not packages, package.json. These scripts and these dependencies, I might diff those. And so once I've got the new project with all of the new dependencies kind of set in place in my old project, now I've got TypeScript running. The other way, if I have an existing project that maybe isn't using the Vue CLI or has grown very differently, then I can say tsc -init, and tsc-init will start to generate that tsconfig file. Now, I'm sure you're going to want to tune your tsconfig to meet your specific needs. And so that will just get you started with the bare bones tsconfig. But then what version of the browser do you expect to run in? What libraries are you starting to consume? What paths do you want to include or exclude? Those options you may want to tune after the fact.
Thank you.
Yeah, that was a great question.
I have a question about the event that you showed us. Looks like that event was from component to a sibling component. What's the scope of the event in Vue?
What is the scope of an event? That is a good question. Let me close all and pop open that component. Here is the counter component where I'm emitting this event. Is that the one that you were talking about?
Yeah.
And then here in my views, I have this playground.view, and playground.view is the one that pulls it in. So I have the counter component, and I'm putting it on the page right here, and I'm listening to it. So it's not actually a peer component. It's a parent component that's consuming it.
So it's
But
like
I could
master child in Angular.
pass it in there. Sorry, go ahead.
So it's like a master child in Angular. The parent can listen to emit from child. That's what's going on.
Yes, it is a main child arrangement where the main component can listen to the child. The parent can listen to the child.
Mm-hmm. And the change detection, what's the Vue equivalent of the change detection? Is it the same or some different concept?
It is. It's exactly the same.
Same. Okay.
Yeah. And if you're really sold on Redux, that's what the Vuex store is it is this mechanism. It has components renamed a little bit. In this case, I didn't dial it out, but we have our state, we have our mutations, which are Redux commit. We have actions, which are mashing languages in my head. Yes. And then modules where we can nest this. So I can create all of this piece inside of another file and nest that as a module. So sub thing pulled in from some other thing. So maybe I import child store from. Now, of course, that doesn't exist, so it's going to do bad things. But now I have a nested Flux store, which is really cool.
Thank you.
Yeah. I learned the Flux pattern inside Redux, and then I came to Vue, and I'm like, that is so cool. One of the things that's particularly awesome is mutations in Vue are must be synchronous in the same way that they must be synchronous. Commits must be synchronous inside of Redux, but actions like dispatch inside Redux. I think actions can be asynchronous in Redux, but they can also be asynchronous inside of Vuex, and that's really cool. I don't think they used to be asynchronous inside of Redux, the dispatch functions.
And way back when you had thunks.
Yeah.
Thunk.
Yeah, so you had to do thunks to get them to kind of pretend to be asynchronous, and yeah, actions are asynchronous already, which is really, really cool.
So how do you feel about all three being in the same file? Does it work well for you?
My Flux store?
No, I mean the HTML, JavaScript, and CSS all being next to each other.
I really like it. I like that my HTML is in HTML and my TypeScript is in TypeScript, and that they are in the same file. The guy who made Durandal made not Aurora. Oh, I lost the library. It's an amazing JavaScript library, and he has three different files. So you have an HTML template file and a JavaScript file and a CSS file that just all happen to be named the same. I think it is Aurora. And that always bugged me because I was always flipping between them. And then if you had Webpack bundle it, you had to name it very carefully so that Webpack could bundle all the things. In this case, all three pieces are right in one file. And so I can just cruise up and down to go find the other pieces. Specifically, scoped styles are amazing.
Yeah, and it's basically a web component.
It is.
In fact, it's like
Aurelia, that's what the framework. Aurelia has this thing where, based on naming conventions, the HTML template and the web component declaration are in two different files that just happen to be the same name except for the extension. This has been a lot of fun. What do you think of Vue and TypeScript? Do you think this is a good option for your next project?
Of course.
I remain skeptical. I mean, I guess I can see pretty much what you said, that if it's a relatively self-contained and your team is on board with this, and you don't have to worry about pulling in outside code and keeping the definitions up to date, I can see it being useful. But I can also see that updating the type definition files as being a big sink of time without at least not clearly worth the time you sink into it.
Yeah, I agree. If you use a whole lot of JavaScript libraries that don't have type declarations, it can be quite a time sink. And what's interesting is today we hit all of the places where we didn't have type declarations, but more times than not, I end up finding type declarations. And so it's really easy just to pull in their library.
I mean, how often do you need this sort of libraries in the front end? I feel that's more needed with backend Node.js development. In front end, usually you don't have that problem that much, I feel.
I agree. I think, the back end is where the majority of the computation happens, but you can use libraries for components like a select list or a table that renders as a grid with filtering and editing. And, those types of libraries are really helpful on the front end and things that you wouldn't use on the back end.
It also depends on the complexity of your front end app, because if you're building offline first apps, there is no back end, or at least it's an afterthought rather than a forethought. So as someone who's built or worked on offline first apps, you end up pulling in a lot more libraries than you would expect for a front end. My main comment about the type definition files was going to be that libraries, for the most part, are fairly stable as long as you pull in a specific version. So honestly, even if you don't find a type definition file, that's one step where you could, if you don't feel like stubbing one out, just throw a tsignore in and feel pretty confident about it.
Yeah. I throw a tsignore in until it bothers me, and then I cast it as an any until it bothers me. And then I go create a type declaration file defining the small pieces of the library that I use, just their front end public interface. And usually that gets me through the door.
Yeah, I feel it can be very progressively introduced. It doesn't have to be like an all up front sort of mission.
I was trying to find it, but there was a tweet recently of a library developer who kind of spent like a year or spent a while going TypeScript first for his library, and his tweet was that he regretted it. I don't know if anyone else saw that tweet. So that was it's kind of interesting. TypeScript is definitely has a lot of benefits, and I'm kind of skeptical a little bit on some of whether you should just dive into TypeScript right away or just use JavaScript and learn JavaScript solely for JavaScript's sake. And I think personally, it's really the dependencies and the packages that cause the most issues. But if I have to natively use TypeScript because it's a TypeScript project, I feel no problems really using it.
Yeah. If you can swim only in a TypeScript pool, it becomes much easier.
Well, here's a question. Does the compiler or TypeScript do some sort of like tree shaking, so that, say, for example, you're only using like that one function in Lodash? Do you need to have all the definitions, or can you on the fly just create your own definition for that one function that you're using?
The cool part is that TypeScript is a design time piece. And so you only need to build the type declarations for the things that you're actually using, whether it tree shakes or not. What's cool, though, is that Vue has a Webpack bundler underneath. And so it's actually doing tree shaking with Webpack to be able to do what tree shaking does. So I'm still delivering less code to the browser. But the type declaration files is really to help me with the red squiggles on places where I'm calling a library and it's not the way that it behaves. So yeah, I only need to build the type declaration pieces for the part that I used. In our application, we actually did exactly that. We said, I would like to build this type declaration only for this one Lodash random function. I didn't need anything else because I didn't have any red squiggles for anything else. And I could have said, well, TS ignore, and it would have gone, okay, fine, I'm done. But I actually have the ESLint rule that says TS ignore is not allowed. And so that wouldn't have worked in this case because I specifically disabled it.
Well, thank you for that answer. One last one for me, at least, is you mentioned unit testing. Say, for example, you're using Vue test utilities. How does TypeScript go into that? Because lots of times people don't really talk about the testing part, but do you use TypeScript in the testing side of things too? And how far do you go in that?
Yeah, Vue test utils does have TypeScript definitions. And so as you harness your component into Vue test utils, then you can get all of the TypeScript goodness there as well. There are two different, no, that's Storybook. In Storybook, you have two different syntaxes and TypeScript is only supported in one of them. But in Vue test utils, I actually really enjoy it because while in TypeScript, all of my component pieces are exposed in the way that they are, and I get extra red squiggles inside my tests when I'm calling my components incorrectly.
I mean, do you need to like include some special syntax to get the test to import, or is it basically all considered part of the same project, so you don't have to have like the import TypeScript declarations, for example?
What's cool is this tsconfig defines my code, the TypeScript compilation options in this project. So if I were to come in, and I'm not going to pull in all of test utils and do all the things, but if I come in here and I say, not there, here, tests, new folder, test, and then I'll have unit tests. So new folder, unit. Then here inside the unit folder, I will have a new file that is tsconfig.json. And this then defines the TypeScript environment for my tests. And so now I'll have a similar mechanism. I could just, duplicate all of this and set it over here. But by the way, modify a few things. But in this case, I'm probably not going to do that. I'm probably going to say extends ... tsconfig.json. And I don't recall if I need to specify tsconfig or just the path. But now I only need to override those few options that I need for my environment inside my tests. But then once I'm building out my tests, yes, I'll pull in the types for all the things. We saw an example right here, where we pulled in an interface. And so we'll do that in our tests as well. And that's really cool because I can say, and the type of this thing is a customer info or a product or whatever type I want. And then I can build up that piece, inject that into my component, and I know I've built that nicely. What's really cool is as I add a new required property into my object, then my tests will go, hey, your fixtures didn't have that additional property in it. And that can be really helpful in being able to tune my tests to match my evolving application.
Yeah, kind of a personal question on TypeScript. How often are you using private methods in your Vue applications with TypeScript instead of like a class?
How often am I using private methods? Not very often at all. I learned Node in Node 0.4 back before private methods existed. And so I got really good at ifs, and I also got really good at building small modules so that in that one code file, I could create the pieces that I needed to expose just right there. So at that point, I haven't needed private members. How about you? Do you find private members helpful?
I personally, yeah, I personally figure it should be public. I mean, if it's a web application, it's going to be somewhere in there. It's not like a file thing. But I find like since TypeScript, a lot of backend developers like TypeScript because it's types, and then they're like, I can do the same things I did in .NET or C# or Java, and I have private methods and private. And it's like it doesn't really work the same way ish. It's kind of, I mean, now we have actual private stuff in JavaScript, but it's harder to test, right? You start making these stateful functions.
And in particular, deep nesting chains. They're like, I have types. Let me create this really big inheritance chain. No, it was a bad idea when we did that in C# as well. Composition over inheritance.
Yeah, small functional methods are a lot easier to test.
Exactly. Inject in your dependencies, and at that point, then you can fake them out in tests, and you can do some really powerful things.
Rob, I'm more familiar with inheritance than composition. What is composition?
Inside this, actually, I'm not sure if I have an example of this. Oh, I think I do. Here in these views, not that one, in my playground. I'm pulling in all of these other components. And so I'm not inheriting from them. I'm pulling in these small pieces of functionality and using them. If I were to create, let me create a new file. I could say, here's a class. And so public class Vue. And I need a constructor. Well, anyway, I have a Vue class. And I'm going to say public class bar. Oh, that's wrong. That's why it's mad. Bar extends Vue. So now if I have, it doesn't like public. Yeah, I'm pretending it's C#. Export. Here's two classes, and this one inherits from that one. That's interesting. If I create a property here, get stuff, then in here, thing, I can say this dot get stuff, and it will call into this base class method. And that's really cool. I can get kind of free functionality. But now what if I want to test thing? The only way to test thing is to call in, and so I have to understand how this method works instead. Rather than doing that, let's say this foo is in one spot and this bar is in another spot, and I'm going to say import. I'm going to pretend these are separate files. Import foo from foo. And now because I've imported foo, now I can say in my constructor, this dot foo equals new foo. And then in my thing, I can say this dot foo dot get stuff. Now I'm still instantiating a new foo, so probably I'm going to want to export functions here instead of classes. But now if I did that and I just pulled in foo as a class, I could not even declare an instance here, and I could just say foo.getStuff. And at this point, I'm presuming it's methods, so it's lowercase. But now in my test, I can inject a fake foo. And if I inject a fake foo, now I can test this method without having to also test the innards of this other library. This is composition. I've taken these other things and kind of mashed them together rather than inheriting from them. And part of the beauty there is I'm starting to make my components a little bit more loosely coupled so that I can test them individually. If I inherit, they are very tightly coupled because, well, one inherits from the other. And so I really can't deviate from the functionality in the base class without a whole lot of effort.
Do you use composition a lot in your C# programming?
Do I use composition in my C# programming?
Yep.
I do. I could say bar extends foo. Let's pretend this is C#. And do a similar kind of thing. So this would be bar, and I would say call the base class. Wow. TypeScript really doesn't like the C-sharpness of this.
Change the extension of your file.
Good call. Rename. There we go. So I'll have some using statements here. Bar, and then I can say thing, and I can say this dot get stuff. Similar mechanism, I'm bound by foo's definition of this thing. Well, that's kind of annoying. Let's come back up to this, and we'll say public class foo, and we have this public get stuff method. And then in Visual Studio, I hit Control Dot, and up pops this menu that says, would you like to extract an interface? And I say, yes, please. Public interface foo. It says public get stuff. And then this becomes foo. And it does that for me automatically, just when I say extract interface. It is wonderful. You can either choose to put it in the same file or a different file. Now I have this foo interface. I'm not going to inherit from foo anymore. Instead, I'm going to take in an foo. Now I need to create a private foo, and I'll probably make it read only. Because, then I'll say this dot foo equals foo. And now I've instantiated, now I've accepted this dependency. And when I need to call into it, I can say this dot foo dot get stuff. In my test, I only need to satisfy this foo interface. So I may choose in my test, let's go create a test. This is public class test bar. And this is public void test get stuff. Arrange, act, assert. Here in my act, I'm going to say, well, in this case, I'm not returning anything, but var results equals bar dot thing. And now I need a bar. So let's say bar equals new bar. It needs to take in a foo. Okay, so I need to create an foo equals new. Now it only needs to be an foo that matches this interface. Okay, let's say fake foo. Well, what is that fake foo? Public class fake foo inherits from foo, and I have my public void get stuff method that returns whatever I want. So fake data. Okay, so I can create a constructor for public fake foo that takes in fake data. Let's say it's an int. This dot fake data equals fake data, and so I need a private property here. Private int fake data. And now, because I'm returning exactly what I want, I can pass in int expected equals 7. Random number. I'll pass in expected here, and then I expect this to be some results. And using Fluent Assertions, because Fluent Assertions is awesome, results dot should dot be expected. What does this actual method do? I don't care in this test. This test is not about testing a foo, it's about testing a bar. And so I want to know that this bar works as expected. So that's what I'm testing in this case. Because I did inheritance, or because I did composition, I injected in the dependencies that I needed here. Then I was able to fake out the dependency and do it in a different way. If I had inherited from foo, I couldn't fake out that dependency.
Oh, thanks, Rob.
I would like to mention one thing. The guideline is favor composition over inheritance, which is not to say that inheritance is the wrong answer always, right?
Yes.
Only a Sith deals in absolutes. We're not going to do that here.
Yes.
There are plenty of valid use cases for inheritance. It's just we're reminded to favor composition because it's a little more flexible, and we sort of instinctively want to go to inheritance instead.
Good call. Inheritance is not the source of all evil.
Humans are, yeah.
Yeah.
I thought it was funny.
Where I'm skeptical about composition over inheritance is when it's applied to domain design. I think it breaks down an alignment between the code and human brain. And when, say, for instance, I always think of vehicle is a car, and vehicle having a car, to me, it sounds very weird.
Yeah.
Well, to push the metaphor further, it's a vehicle has an engine, and so
yes, vehicle
right.
having an engine is perfectly fine, but Cadillac having a car, that's to me weird. Yeah, well, and that is weird actually. And I think that's actually the wrong metaphor too. The vehicle doesn't have a car. A car has an engine, and a truck has an engine, and a airplane has an engine. And so that's composing it, making it up from smaller parts. Right. No, obviously you would not inherit Cadillac from an engine, but I would inherit Cadillac from a car. Yeah. Yeah, that's an.
But what value is car in your application? Is that going to really help you? Or is vehicle really the class that you care about?
It might. Maybe I'm doing some, interface programming against the interface, and I'd like to program against the car. Vehicle only comes into play every once in a while.
Yeah, that makes sense. At that point, as I'm persisting it, do I do table per type or table per hierarchy? That's when my database schema starts to suffer as well. I think I would rather just have a car class and maybe vehicle add-ons that become additional things. Inheriting at that point makes my database schema really squirrely.
Or maybe I'm doing event sourcing at all.
Yeah.
Cool. We ended
That
up.
was awesome.
We did some C# at the JavaScript.
That was awesome.
It's okay.
That was
Last
good.
month I did
It is
Python.
You did Python in the middle of your JavaScript talk? That sounds amazing.
Well, it was a machine learning talk, so.
Yeah, and machine learning always descends into Python.
Yeah. So sorry, Gene, I didn't mean to talk over you, lag and all. What were you saying?
I just want to say that that little interaction where you explained composition over inheritance and then also interjected the wisdom of not always evil.
Yeah.
That was just awesome.
I think that's an important lesson about all things, well, period. But in computer science in particular, there's I was discussing this the other day with someone about whether should you always pair program? Well, the wisdom is in knowing what kinds of problems work well when you pair, what kinds of problems work well when you mob, what kind of problems work well by yourself, right? There are actually different types of problems you're solving that any of those tools are applicable. And whenever, anyone says always or never, that's always and never wrong. No. But, and so it's always the wisdom of knowing how to apply the tools in one. And so inheritance and composition are the same thing. This applies to, when do you have relational data versus hierarchical data, right? If your data is relational, you end up with Cartesian products, and it can expand, into too many permutations, and so you hierarchize. It's the way you scale the problem of too many permutations. But that doesn't mean that working through permutations is bad. It just means you have a reason why you would do one versus the other. So this stuff comes up all the time.
Good call.
Sorry, I didn't mean to take over, Rob.
Oh, it was perfect. I was going off on a tangent and you pulled us back in. It was great.
Yeah, great. Cool. Are there any other questions? We're hitting the hour and 40-minute mark, which I'm fine with. We're still streaming too. So
nice.
As long as the conversation's good, then it makes good YouTube video and Twitch content as well. So
yeah.
Okay. Well, I think that's probably it. Does it seem like it's it to you too, Rob?
Yeah. Matthew asked a really good question. What's coming up next month, Guy?
I always forget that too. So next month, I am 90% certain. We have Jeff Blankenberg. He's going to be talking about Alexa. Ooh. So understanding Alexa, he's got a 2-sentence abstract. This session will unpack how Amazon's Alexa works, how you think about building voice user interfaces, and which best practices you should consider as you build skills. We'll cover this using the Alexa Skills Kit SDK for Node.js and the ASK CLI. So how to build an Alexa skill with Node, which sounds fun. So that's next month. Yeah, I think that's pretty much it. So I'm going to go ahead and shut down the Twitch stream. Everyone on Twitch and on YouTube, thanks for watching. And if you have any questions, feel free to leave a comment below. Of course, obligatory like and subscribe and all those sorts of things. If you want to find out how, the way that you can hear about more videos from the Columbus JavaScript user group using this one weird trick is by clicking the like and subscribe button. So, so thanks everyone, and ending stream now.